Hi, I'm Robert, and this is the SANITRX department at CDC, and we make sanitary scored reverse acting rupture discs. We make them for pharmaceutical, biotech, food and beverage, and any industry that needs cleanliness in their division. How we determine how these rupture discs work is by three basic things. Is by the thickness of the metal, by the height of the crown, or what we call the crown height. If we stretch the crown a little bit taller, that creates a higher pressure disc, a little stronger. If we lower the crown height lower, that creates a less strong disc or a lower pressure disc. Also, we control the brake by the depth of the indent. A lighter indent will make a higher pressure disc, and a deeper indent will make a lower pressure disc. When the air starts to build pressure on the dome of this disc, this indent becomes the focal point. As that pressure builds up on the dome, this is where you're going to have your failure at. So the depth of that helps control where it will fail. A deeper indent gives it more room to concentrate on, and it will fail sooner. A lighter indent will take longer for that air to get down into it, and it will make the disc break at a higher pressure. Those are the three basic things we use to control the break of our rupture disc. Now, after we've got our metal, we come over here, and this is our form die. This die is going to do three basic things in one step. It's going to blank the rupture disc out, it's going to form the height of the crown, and it's going to place the indent in the dome. These are all adjustments that we can make. This is our adjustment for our crown height. We can raise it up or lower it. This would be our adjustment for our indent. This can be raised or lowered and adjusted, so we can adjust for our indent. This die closes, pressure builds up. As it ramps up, we call that the ramp rate. This machine here controls the ramp rate. The amount of how fast you stretch a disc will determine its break also. If you stretch it really fast, that'll change the break than if you stretch it really slow. So it's critical that you have a consistent ramp rate. And that's why we have this called the automatic former. It controls the ramp rate at the same rate every time, so you can consistently hold your brake. After we have formed the dome, then we take the disc and we come over. This would be our score press. It consists of a blade. This is what places the score in the disc, and an anvil. And this is our adjustment wheel. These are 10,000ths increments on this wheel. On a scored reverse acting disc, the score is the critical part. If you have a disc to break under air, air is compressible. It will compress and it'll just blow that disc open. But if you have a disc that is in a liquid surface, liquid isn't compressible. So you're going to have to score it a lot deeper and make the disc weaker for that liquid to open a disc. So this score becomes real critical on making this disc operate right. If the score's not deep enough, it'll reverse and not open. And if the score's too deep, then the disc will crack before it reverses. So this here is very critical in making the disc operate under air or under liquid. After we've scored our disc, then we would come over here to the weld table, and we would spot weld an outlet ring onto the disc. We have our settings, and we have a weld log to tell us what settings to use per thickness and type of metal. After we've welded that on, this is what the disc would look like.
Okay.
Then we would come over to make our brake under air. Here's where we would put our gasket on. This would go on our volume tube. And we would torque it down to the appropriate torque. Then we would fill this with air. These are our gauges. Then when that disc reverses and opens, it'll be recorded on the gauge panel. And then we would make our appropriate adjustment, higher or lower, depending on the pressure of the work order. So that in an overview is how we would make a scored reverse acting rupture disc.